Hello everyone, my name is Patrick, and today I'll talk about how to improve your web development velocity by using Typescript. All right, I think we're good. So this presentation is really code-oriented. I'll provide lots of features about TypeScript very fast. You will see I'll be breathless a few times during the presentation because I try to bring as much features as possible. And the idea here is that maybe one or two aspects that I will present will be interesting for you and gonna give you the little bit the curiosity to give it a try. And usually presentations start with an overview of the presenter, and instead today what I'm gonna do is provide a JavaScript function that's gonna describe myself. And we're gonna transform this JavaScript function into TypeScript, which will allow us to test a little bit of the features. So like everything, we're gonna start with importing the library. So we're gonna pretend that the Shift conference is presenting us with a library that we can use. So we're gonna use npm import this library. And this is something interesting for TypeScript. You don't need to use anything from Microsoft that is proprietary to get the library that you want to use. You just use the tool that you're already familiar with, which is npm. You're getting your source code from there, and then you can use the library. So like in this code right now, I'm importing my library, and there's nothing that I needed to do more at the moment. The next thing in this slide is I'm using the function whoAreYou, and I don't exactly know how to use this function yet. So definitely, like anybody, the first step is to go look at the documentation and see if it's available first, and also if it's still synchronized with the actual library. And then there's many other options that I can use. I can go on GitHub if the source code is open source, find out how it works, read the test, and get a little sense of how it's used. I can search on the internet, find out on Stack Overflow. But the whole thing is that it takes quite a long time every time I'm looking for something. And at the end of your day, if you're always back in your browser looking for how something is supposed to get called, then you're losing a lot of time. And that's a little bit the idea with TypeScript. So here right now, I don't know if this function is taking numbers, dates, strings. I don't know if this object is an object, first of all, or an array of information that I need to pass. I don't even know if this function is returning something or not. But what if I could find something that lower my learning time as well as increasing my understanding of every libraries, but also of my teammates' code, and also avoid errors? Well, I would say that we are one step toward this mythical 10x developer. So I'm not saying here that using TypeScript you become like 10 times productive. What I'm saying is using the right tool for the right job is always the way to thrive into efficiency. And TypeScript is one of this tool. So before I jump into more coding, I have one slide that I'll put a little bit more emphasis of how TypeScript improve your level of understanding. And it's at different level as well. So it's gonna start at your level, and then at your team, and at some point more worldwide with all those third-party libraries that you have. So how this start? It starts with yourself. First of all, you're gonna have a way better understanding of your own code when you come back after a few weeks, because the type's gonna describe a little bit more your intention that you had and that you had forget probably. But one of the most powerful thing is that the types allow you to bring some self-reflection in the process of developing your code. Because when you're using JavaScript, you're still using those objects. You still think in your head about, oh, this is going to be an integer here. That's going to be a string. No, that's going to be a date. You think about it, and then you use it. But what if you take a step back and you write these officially into a type? Well, it's the same process that your mind is going to do when you have an issue on any problem in the world, and you take a white sheet of paper and you write it down. You get some kind of perspective, and then before getting involved into the code or trying to solve the issue, you can just adjust your plan a little bit. And TypeScript allows this kind of reflection before being too involved into one direction in your code. There's many other things that it helps. first of all, it helps with your team as well. When you're going to do a pull request, for example, you're going to read the codes way more fast because it's going to be easier for you to understand the whole code because you're going to figure out, oh, yes, I understand this object is passed there. It's easier because it's named. I understand the purpose because I know exactly the type, and I know that this is going to compile, so I don't need to do any comments about, oh, are you sure that's going to work or not? So it helps to be a little bit faster in your pull request, as well as when you are merging, because when you're merging, there's always code conflict. And all those resolutions can also become problematic. Maybe you're not merging the right thing in the right time. But with Typescript, you're going to get constant feedback about if your resolution is working or not. And since you're writing those contracts, which is the types, this can be shared to your team definitely. And if you're doing so, it's going to increase your velocity, because if somebody is building those entities and those types and it's used across the system, then you don't need to rewrite those types. They're already there. So it's shared. It's like a documentation that is always living because those types are always compiled. This is a little bit different than GS docs, which can be a little bit unsynchronized at some point, and then you need to not rely on them. But it's completely different with TypeScript because it's always up to date. And there's definitely other good improvement, like if you're getting new packages, a new version, and you want to be sure that this one is not disrupting your whole project. When you're doing an NPM update, you're going to see exactly if the code is still compiling or if it's not. And this is a good feature because you can update and see if it's destructive or not on your project and move on if it's fine. Otherwise, I'll just roll back and do it later. So it gives you a good sense that before even running unit tests, if something is wrong or not, and so on. And I would say that the last point is it smooths the learning curve on any new library because you have this guided path when you try something. If you try a new function, a new class, you cannot go really outside the range of what is limited by TypeScript, which is in fact also limited by JavaScript, but you don't really see it since you don't have this strong type nature. So if you come back in the our code, the first thing we're gonna need is to use a definition file, which are the contract that you share across your team. In that particular case, getting the definition file for the function that was there previously give you that the who are you function now takes an object of type speaker. And this type speaker is defined by the interface, which right now is empty. So definitely it could be better now, but it's one step into getting a little bit more strongly typed. Concerning those definition files, they are important if you're using third-party library, and there's more than 4,200 available in one of the most active GitHub repository right now, and that's just the peak of the iceberg because more and more library provide those definition files directly into their NPM package. And that's the case for very popular framework, like, for example, Redux, which is built in JavaScript, but provide the definition file for TypeScript in their main repository. So at that point here, even if it's not great, it's better. Because now, if the who are you function signature change, I'm gonna get a compiler error. So I'm gonna get feedback directly at the first step of any change, not having to wait for unit tests, not having to wait for runtime. I'm gonna get it right now. So I'm getting a new version. This time, the speaker interface is providing me a list of members. Still not perfect. So on the left side, you can see that I'm getting all those members that are required, which means that they must be defined in my object. However, on the right side, you can see that everything is any. So any in TypeScript means it can be anything, which means that we are still on the field of JavaScript. So on my name, I could put Patrick, but I could also put like a number. So it's not great, but it's better since I have to provide name as at least. So if I start typing my function, TypeScript is going to give you feedback all the time while writing your code because the IDE that you're using is directly connected with TypeScript and they talk to each other. Within a few milliseconds, they're going to tell you what's going on. So while I was starting typing stuff here, something was wrong. And why it was wrong is because some of the required fields are not provided. However, if I provide everything, then the compilation is successful. So right now I provide some data here about myself, but definitely the date here is not gonna go very far. But still, I can do it in JavaScript. I can do it in Typescript as well if it's the type is any. So I'm getting a new version here of this library with npm update. And right away, I'm getting feedback. I'm getting feedback that something is wrong. Everything is red, so I know it's wrong because it's red. But I'm getting this feedback before running unit tests. And not only that, I'm getting it directly in my ID. So if I put my cursor next to the error, I'm gonna get that something is wrong with my name. So from there, I can go look at the definition file and see that, oh, something has changed definitely. Now the name is not anymore any, it is an object. And this object contains first name, last name, and middle name, which are all strings. And the second thing is that developer sync is now a date. So I'm getting all this information without having anything to do else than pulling the code. And this is true not only for a third-party library with NPM, but also with your teammate. If somebody is changing the code, then you're gonna get this feedback directly. And also good and true about yourself when you're doing refactoring. You're gonna get that feedback all the time. So I like to think about TypeScript like having a peer programming buddy on your shoulder, looking at your screen all the time, telling in your ear, hey, there's something wrong here. It should not be like that. Directly while you're typing. So this quick feedback here provides you this hedge to be way more productive in your day-to-day. So all this little time that you're wasting and getting these errors in your browser, now you're getting it at a really quick pace. And next is I'm getting a new version here, and this one I'm providing the features I'm providing the value from the contract. So first of all, the name now is split in the object. You can see that I don't have any middle name, so right now I'm putting an empty string. So I cannot avoid this field at the moment because it's a required field. So we'll see how we can improve that later. Developer sync is also a date now, so we're good to go. We're getting a new version of the same library, and now the date is changing once again. Instead of being a date now, it's using a library that is called moments.js, which is pretty popular as well to manipulate code around dates. And what is interesting here is that moment.js, like many popular library, provide their own definition file with the main npm package. So without doing anything, just starting typing moment, I'm getting this feedback right here. This is the format of Visual Studio Code, and it's providing me types information about what I can provide as the first argument. And I was thinking about using a string when I was doing this slide. And when I was typing, I figured out that I could use also all these other types, which is number, void, moment, as well as this interesting object, which is the last one in the list, moment input object, which I never use for forever that I know that library. And this is really important. So now I am learning something while I am just typing my code. And this aspect of TypeScript accumulate through the years that you're using TypeScript. So you're making those relationships in your head about, oh yes, when I'm using moment, I can pass this object. I don't even know what it means or how it works, but later on when I'm gonna use moment, I'm gonna see again this moment input object. And now I'm gonna start making relationship. Like this function returns this object. This function takes as a parameter this object, and so on. And that's true for third-party library, but it's also true for your own code that your teammate are building. So if you're having somebody onboarding on your team, it's way easier with Types because you can start making all those relationships about the code and where things move and where things are used. So there's a big gain here with TypeScript. You're getting IntelliSense as well when you're doing a dot on anything. Documentation is coming through the IDE that you're using. In that particular example, if I'm using dot, I can get all the public accessor of moment. But this is very interesting if you're using a string or anything like that. Lots of people don't remember the difference between slice or splice, for example, but you can get all this information in the IDE once again, the goal here is to be efficient, is to stay the most that you can in the IDE without having to jump back to your browser all the time. One other feature that is interesting with types is that you can dig into the signature of many types and jump from one type to the other one. For example, here, there's this feature in Visual Studio Code, which is available also in many other code editor, which is that you can dig into, to go to the definition of a file. So in that particular example, I just hit F12 on moment, and I was inside moment.js definition file. I just scroll a little bit, and I can see all what is available for me. So without getting into big detail, I still have a shallow view of what is possible with this library. Okay, so Enum, if you've been working with C# or Java, you probably have used Enum. This is a function, features of Typescript that allow you to specify for a specific member a value that is conscribed to a specific set of value. In that particular case, I'll be able to set up my favorite editor, and only 3 values are possible, which are Visual Studio Code, Sublime, or Atom. So at the end, I can do stuff like this switch case and having something print to the screen. And what is interesting here is that if on the Enum side I remove, for example, Sublime, Typescript would already indirectly told me that, oh, this code is not going to work because I'm referencing to .sublime, which does not exist. So Typescript protect me about change that happens somewhere else and then trying to access it that does not exist anymore. There's some pattern like the exhaustive check pattern, which do the other way around. So imagine that right now that I want to be sure that every possible value are covered. So that's going to work this pattern for Enum, but also for other type of types. So what's going to happen here is that if I remove the case that was handling Sublime, but keep it in the Enum, the code will fall back to the default case, which is something that I would not like. Let's pretend that. So instead of having an error at runtime or having the code falling back to that default and having to do a special case for if something is not covered, what I can do is having this exhaustive check function, which takes a type called never, and it should never happen. So Typescript is bringing a little bit more than what you were used to have in JavaScript. But what it had, it's only stuff around types. So Typescript is really a superset of JavaScript. So everything that you can do in JavaScript, you can do it in Typescript. The thing that Typescript is adding on top is about types. And this is one of the features that is adding, is this type never, which should never happen. And the compiler will figure out that, oh, Sublime got removed, then it goes into this default case, then it calls this function, and it should never happen. So it's going to break at compilation time, not at runtime. So you're getting, once again, some feedback really rapidly. So let's stop here. So once upon a time, I was not fond of Typescript. In fact, when I moved to Microsoft 4 years ago to work on MSDN website, I was supposed to just work on JavaScript and C#. But like any big corporation, there's lots of movement, and then I got moved to Visual Studio Online website, which is now called VSDF. And everything was moved from JavaScript to Typescript. And I was like, oh, is it like the next ActiveX Silverlight Microsoft thing? So I was a little bit like on the defensive for a few hours there. And it was a little bit after a few days, still was not convinced at all. I was coming from C#, so all the object-oriented richness was not there in Typescript at all 4 years ago. It was quite a disappointment here. As well as trying to be more functional, the feature were not there at all also. And at the end, it was very slow. So it took me several months to start liking Typescript. But right now, I understand that, oh, it's not this Microsoft proprietary technology. It's something, first of all, that is open source. Secondly, it's using all the greatness of ECMAScript, just adding on top of it stuff about types. That's great. The object-oriented is now well supported, as well as all the functional things. So you can go on both sides without having to change your style. So everything should be covered for you. And this is possible because the team is really active. Every 2 or 3 months, they're providing a new version of TypeScript. And they work closely with all those big frameworks, with Angular, of course, because Angular is built on top of TypeScript now. But they also work with React and other frameworks to find out how they are using TypeScript, how they are using JavaScript, and to make TypeScript always compatible and having types to make it easy to have strongly typed code. And also it was slow, now it's pretty fast. I've seen it and, with millions of lines of code, and it can compile within a few milliseconds, depending on how you configure your TypeScript, of course. So now, I would say that unanimously, people enjoy the benefits. So that's a bold statement, but the key here is that it's going to take time. So if you're coming from JavaScript, moving to TypeScript, usually it takes like 2 or 3 months to get used to it. At the beginning, it's just annoying. Like I said, it's really like a peer programming buddy telling you everything that is wrong. And if you're not used to use type, then everything will be wrong. Even if you're very good in JavaScript, it's easy to go on the wrong way. It's easy to do some hack here and there. With TypeScript, you cannot do all those hacks because a string is a string. If you want it to be a number, then it should be a number. But sometimes it's easy to just go around in JavaScript, stuff like that. Universally found issues in existing code. That was true when they migrated lots of code from JavaScript to TypeScript at Microsoft. It is also true at Netflix. When I joined, I migrated a few projects over here, and we found minor issues here and there. Even if we have unit tests, even if the people that are working there are all amazing, we found some issues there, and it's normal. There's nothing that can beat a machine to figure out all the possibility on a huge code base. Webpack is not built in TypeScript at all, but recently they are running TypeScript on top of their JavaScript to get a little bit of the goodies that TypeScript is providing about the analysis of the code. And they found some issues there also. Slack, a year ago, they published a big blog about how their engineering moved to TypeScript and how they were surprised that they found so many errors in their code. And the last example here, I have Lyft, which I learned recently that they were tagging in their bug tracker all the bugs that could have been avoided by using TypeScript on the first place. And at the end, it was so much tagging about TypeScript that they decided to just move with TypeScript because they could reduce the amount of bugs that they were pushing through. So this increases your velocity. You have less time spending on fixing things that TypeScript can give you right away. The last point that why I really like TypeScript is that it's grandiosely scaled. And by that I mean, right now I'm working on an application built on React with TypeScript. It's about 35K lines of code, so 35,000. So it's pretty small. And I'm almost the only engineer there on the front end on that particular project. And I can rely on TypeScript to reduce my number of unit tests. I'm doing all the unit tests for my business logic, but I don't have to do all the unit tests, for example, for, oh, is this parameter a number? Is it optional or not? All those kind of unit tests are not there because I can just rely on TypeScript. So I can be very efficient, and I can produce quite a big number of lines of code, even if the number of lines of code is not a major critical aspect of saying if something is successful or not, but still, I would say that it helps for small projects. A year ago, when I was working on Microsoft Teams, which is Microsoft Slack product, it has about 375,000 lines of code, and the team was way larger. It was using Angular as well, so another framework, another kind of scale, so I would say that it's probably a medium-sized application at that point. It was working pretty well with a different configuration, but still very fast. And on the other end, Microsoft Visual Studio Online, VSTS, it's very huge. It's like decades of codes there. There's lots of developers as well, so it's really impressive repository there. Millions lines of TypeScript code. It's still working. So you can see that you can start a small project, and this one can grow very fast, and you won't have to change your tooling. TypeScript will follow you through your journey. All right, let's go back in code. So union is a feature of TypeScript that allow you to have multiple type for a specific member. So that's the case here for the visa, which I'm specifying that I can only accept those strings or null if no visa, for example. And company here is using a string, which allow me to put like Netflix, or the pipe, an object which has a name and a started date. So I can have multiple value, which help a lot in JavaScript because a lot of time you need to provide specific types, but you can switch between 2 or 3. But at least I'm specifying which type I'm allowing. Index signature definition, the book one, he's using it. It allows you to use a square bracket. And with TypeScript, you can specify which kind of index you want. In that particular case, the ISBN is the key, which is a string, and the value on the right is, sorry, is a string. But it could have been anything. The value here is my choice. I could have used an object like book, for example. So this allowed me to have this particular line here strongly typed. So from here, I decided to build the type from what I wanted, which is this format, which is a dictionary in JavaScript. Optional, if we remember correctly, I don't have any middle name. So if I had this question mark next to the name of the variable, this field become studently optional. So I can avoid passing an empty string. I can just pass it if I need it, or just avoid it if it's not. Interface and types, those two keywords are used not only for object-oriented scenario, but as well to define the structure of my object. So I can use one or the other. There's a little bit of difference between both of them. I'm not gonna go in details here, but what I'm gonna say is that it has two purposes here. First of all, I can make it more clean. So my object here does not have to have those curly bracket object within the object. I can extract those to make it way more easy to read. For example, now company is way more brief, which allow me to see that, oh, it's string and or company, but it's also an array because of the square bracket. So before it was so long that it was hard to figure out if it was an array or not. Same thing for books. Now, instead of having this big one, I just have books. So that's one advantage. The other one is I can reuse this type instead of having those types to be redefined all the time. And well, the goal here of reusability is that across your system, across your business logic, you start not having all those redundancy. So when somebody starts a project, yes, you're gonna have a little bit of ramp up to build all those types, but after a while, you're gonna just reuse what is already there or extend what is already there. So you're gonna get way more efficient with types. Using type narrowing is a feature that you need to use when you're using type, which means that if you have a type that is using multiple type, at some point you need to figure out which one it is. And the reason is that you need to access some of the function of this specific type. Here, for example, I'm using a string or a company for the list of companies. And what I'm just using JavaScript. With the type of, I can figure out that it's a string, and then I can use on the first if statement, everything about string. However, on the else, I can access now everything about company, which means that if I start typing at design time, I'm getting all the public function of company, which is named and started here. So this is great because since we're using JavaScript, the type of, it's gonna work also at runtime. And this is important because TypeScript is not producing a JavaScript with weird comments or stuff that the browser needs to figure out how it works. TypeScript is really just creating JavaScript that is humanly readable at the end. So you need to have all the solution that is working at design time to work at runtime as well. Renaming. Renaming is one of the refactoring feature or goodies that TypeScript is allowing, which means that you can change something that is related to a particular type. So instead of doing a big search across your whole repository and rename by doing a replace, which could affect a lot of different other company, for example, in that particular example. This one will only rename those that are related to speaker. So what it means is that you can shift code around and make sure that you're not breaking something else, because you're having the tooling that can understand all the types around. Tuple is a feature of JavaScript that you are using which is just using an array and adding types at different index. With Typescript, what you can do is to say, oh, I want to use the tuple pattern as well, but I want to be sure that the first index is a number, like in this example, and the second as well. But I could say, okay, the first is a number, the second is a date, the third is a string. This way, at least I have something that is more rigid and gonna follow me through the life of my application without being too flexible. Also, Typescript is gonna check the size of the array, because if you're using just the array, then you can pass any kind of length of information. With this tuple, for the example coordinate, I will be sure that I can only pass 2 values. Object-oriented, big topic here. I'm not gonna go too much in this one. I'm just gonna say that it's covered almost everything. You can have protected, abstract, override, overload. You can have lots of different features of object-oriented. Here, what I'm doing, I'm just extending an interface, which is something that you can do really often if you're using types, because you want to reuse those types across instead of copy-pasting values and members everywhere. For example, you can have a base model class, which has always an ID, date created, last updated, and have all your entities extending that interface. Discriminator is a pattern in Typescript, which is also used in JavaScript. It's just that maybe there's not the name associated to it, which means that you're specifying a specific field with a specific name with a specific value. So, for example, here I'm having the interface work, and I'm stamping that is going to be a string of work. And on the other one, the second line, the open source project, I'm having also the same kind member, but this time it's stamped with open source project. So this stamping of a string is called string literal, which means that this member can only accept this string at runtime. So for example, here I can still do .kind equal work, which is going to work in JavaScript when I'm going to be at runtime, but also at design time, Typescript will figure out that, oh, if this string is work, it means that the interface is work. And this is important because at the end, when you transpile everything in JavaScript, you're not going to have anything concerning types. Everything is gone because JavaScript does not support types at all. And Typescript is not trying to push anything about type there. However, this pattern is totally fine in JavaScript because this kind property is having the string work, and then the flow of the information can continue as normal. At runtime, at design time, what it's allowed to access those specific members of the interface that we have specified. Other feature, key of allow to extract the members of a specific type. For example, here, display name with the key of person means that I'm extracting first name, last name, middle name, and only these 3 strings will be allowed. And this is interesting when you're using the square bracket to do something more dynamic. In JavaScript, in that particular case, this function without the key of, you could put any kind of string. And at the end, if you put like nickname, for example, this would return undefined. So probably you will have to have some unit tests to make sure that no one is pushing something else. But with Typescript, what happened is that when you're going to specify first name here, your IDE will first of all kick in and figure out that it's a key of. It's going to analyze the structure and give you only the available members there. So once again, even if you don't really understand the whole code around, when you start typing, you're getting all that feedback. Say, oh, okay, yeah, you can only specify those 3 strings. So it helps you to understand what's going on, and it also helps you to reduce, once again, any unit test, because for sure you know that only these 3 values will be provided. Intersection. Intersection is the concept of merging 2 types together. So we could extend as we saw, but we can also dynamically use this ampersand symbol to merge them. And an easy way to understand that is when you're using spread operator, for example, you're merging 2 objects, the values of those objects. But you can see the intersection as also a way to merge the type. So here, this is what I'm doing on the orange square. I am merging 2 types as well as using the spread operator. But the merge goes way beyond just a spread operator. You can just define also a type with social network and experience directly in after the semicolon, which is going to allow you to define the type. Or you can create a new type with the combination of other type. And this can go way more advanced with scenario where you're using generic type that you don't know at design time exactly in the definition, but with the genericity, you can build those type. Talking about generic is supported in TypeScript. If you're coming from Java or C#, you are used to have those lists of T-type, which means that it can access anything of the type T, which means that you don't need to cast and uncast all the time. So TypeScript allowed it by having the same principle, which you can provide a value for the type without exactly knowing what it is, but you can provide at the end something called a constraint, which means that this is the minimum set of structure that needs to be passed. In that particular example, I am passing the started, which is a moment, which means I can pass any kind of object that exists in the world, but it has to at least have the minimum field of started as a moment. So it allows you to create stuff and code that is more generic and reusable as well. For people that are not really into typing stuff, TypeScript allow you to infer value, infer types. For example, this function here does not have any return type, so it's explicit. And this function, in fact, returns a string. And why? Because TypeScript can understand that first name here is a string. And hence, any consumer that's going to start using this function is going to see that the return type is string. So this is a double edge, because if I start changing this function, for example, and now I'm returning a number and sometimes a string and sometimes a Boolean, since I don't have any return type, it's still going to compile. The reason is that TypeScript is going to figure it out that the return type should be a union of a number or a string or a Boolean. So still, even if you don't type it, you're going to get this validation somewhere, because somebody at some point is probably using this function. And if you don't prefer a specific return type, then it's gonna, TypeScript is gonna give you an error at the consumption type. Because before you could use all the features of the string, but now it's not possible to use the feature of the string before narrowing down to the specific string type, which means that you need to use type of string, then use the feature of a string. You can also infer object. For example, here, it's implicit. That's going to be an object with two members. It's going to be intro, outro, which both of them are strings. But I never had to create this object anywhere, so I can just have TypeScript figure it out by itself. So it's another way to play with TypeScript and play with types. A little bit more, I would say, kind of free form. But still a way if you are less into typing as explicitly all your types. So one thing that is interesting about TypeScript is that it's a structural language. It's not nominal. A nominal language is like C# or Java, which means the name has an importance. TypeScript is more like JavaScript, which means that it's the structure that is important. And this is important because right now this quick example here is having two different interfaces, and they have the same structure, which means we can do exactly what I'm doing down here, is just passing from one object to the other, and it's gonna work, it's gonna compile, because TypeScript is smart enough to figure out that, oh yeah, the contract is respected. It's a name, and it's a kind, and the type is matching, so there's no issue moving things around like that. So some people like it because it's more like JavaScript, a little bit more dynamic, allow you to do less mapping between objects. And some people don't like it because they're like, I specify that it's a specific interface with a specific name, and I'm passing something else, and it's still compiled. It should not. So I think you need to put your mindset into that. Okay, it's structural. JavaScript is structural. Then we need to go in that direction instead of fighting it. So finally, who I am? Well, I am a bunch of different members and values and types, and I think this is not really important there. What is important is that if I was to pass like a white sheet of paper to half of this room, and to the other half pass a form like we used to have when we pass any kind of business where it says name, age, citizen of which country or a thing. If I gather back all those sheets, I'm pretty sure that half of the room here would have gave me exactly the information that I wanted in the right format. So for me, it would be really efficient to just read, figure out exactly the information that I needed. On the other way, I could probably find out all this information. Pretty sure I could also, you guys could also just talk to me and ask me questions about it, and I would have told you that I needed to have like the first name, last name, and everything. But at the end, it would have been just simpler to give you exactly what I wanted. And this is what Typescript and Types is providing, is give you exactly what is needed for the system to run in the particular way you want it to. So Typescript increase your velocity in many ways. First of all, it's one tool with many benefits. I haven't talked much about the transpilation aspect, but you can use ECMAScript's features that are really not yet implemented in browser, and Typescript can make it into it. Polyfill and other libraries make it sure that it works on every targeting version that you are specifying. You're going to get a better understanding. I think this is the crucial part of this speech, is that everything's going to get way more clear. It's so clear when you are using, for example, Redux, and you're having all those functions that are nested, and you see all the types for each of those functions. It makes you realize a lot of things, and that's true with every code as well. Self-documenting, you can reduce a lot your documentation, and it's going to be always up to date. That's a great way to have something that is significant for all your teammates as well. Less testing, like I said, you're going to reduce your number of testing. Definitely, you can also focus more on the unit tests that are covering your business logic. Scale and size, I think I gave you some personal examples that I witnessed myself. And it's compatible with all what you have, which means that you can start working with Typescript now on your JavaScript project and start typing slowly. But you could just use Typescript directly on your JavaScript without doing anything first, and then start typing slowly. And day to day, you can continue to ship your features to your customer without any downtime, because Typescript's going to follow you through this journey of starting typing your code. And finally, it's a hybrid. Like I just said, you can continue to work with JavaScript and have half your code in Typescript, half in JavaScript, and it's still going to work. And there's an escape hatch, always. You can always come back to JavaScript. Why? Because Typescript is producing a human-readable JavaScript. You're going to have to fix a little bit the import and export statement. Otherwise, your code will be really readable and reusable as JavaScript. So thank you, everyone. You can talk to me on Twitter if you have any question about how to migrate your JavaScript project to Typescript. You can also follow me on my blog. I'm posting every week since 7 years concerning React and TypeScript recently. So thank you, everyone.